has DevOps Day 1 been? We're clearly all tired and have learned a lot. It's all right. We're all good. It's the end of the day. But hopefully we're going to learn something interesting. We'll have time for questions at the end, so it's all good. So I'm going to talk about observing AI applications. Yes, I'm going to use OpenLit specifically as the conduit to show how you can do this with a TypeScript example. Python is also a valid alternative. But what I want to basically cover for you today is observability for agentic systems more generally, including why it's different, what kind of considerations compared to traditional observability do we need to think about. I'm going to talk about AI tracing, so how the tracing looks, what kind of things are different from a traditional OpenTelemetry style trace and complex microservice architecture that we traditionally deploy them on. We'll talk about evaluations, why they're relevant for production and not just for testing, and what kind of evaluations you'll want to apply. And then, of course, we'll talk about guardrails as well, okay? If you haven't met me before, hello. So my name is Richmond. I lead the developer advocate team at Elastic. I've been there for 4 years, and before that, I spent 10 years in banking building software. So I've been around for a little bit. Now, because I work in DevRel, I collect social media like it's Pokemon. And you guys probably have a particular social where you like to float. So we will have time for questions at the end. If we don't get to your question, you can come and find me at the Elastic booth tomorrow, and I'll be there and happy to chat more about this. But also, if you want to find and connect me, just scan that QR code from my link tree, and you will find me. Now, we need to start with the definition. It'd be rude not to, right? So we're all on the same page. I'm hoping, are we all comfortable? We know what observability is? Good. I see nods. Nods is a good start. So we know it's the ability to collect information about our programs. So we want to know what our programs are doing. So we want to see the internal states of particular modules. We want to see how services and components are communicating. We want to see how they're interacting with things like database layers, Kafka, all these other kind of things. Because that allows us to, one, diagnose issues, bottlenecks, and performance in like an outage or a problem scenario, but also allows us to collect data that allows us to see whether, we can actually optimize our system further. And I think that's something maybe we don't focus on as much when it comes to observability information. Excuse me. So when it comes to telemetry, there's 3 main types of signal. Yes, there is the alpha of the new profiling signal for anyone who's paying attention to KubeCon. But there's 3 main types of signal that we tend to talk about. We have logs, which are these structured messages that we use in order to excuse me, see what's going on in a particular application. And those are useful because we can search for them and we can see what's happening. But one of the things is we don't get an idea of being able to correlate between different services very well. We're really after trying to paint a picture, which can be quite difficult. There we go. Metrics is the next thing. Quantifiable measures. So latency is a good example, as you can see on my screen here. And then, of course, tracing. So is everyone comfortable? They know what traces actually are? Yeah, nod. So we're in an expert group, so that's great. So we know that basically we're able to see the pathway of execution through different layers in our software ecosystem. So you can see an example here where I've got a front-end web service, which is communicating with a back-end Java service. So I can see how long each of these individual stages is taking, and I can see the communication pathway going down the layer. So it all makes perfect sense. So when it comes to observing AI systems, there's a few things that are a bit different. First thing, we need to think about the fact that these models, they're not deterministic and probabilistic as we're used to when it comes to traditional systems. They're making decisions about whether to invoke particular tools, whether to go off and get that particular data, unless we're talking about things like fixed RAG pipelines where it's deterministic and it's always going to come through. And for that reason, we need to basically see and understand what they're doing, because they might call things in ways you don't expect. For example, if we're wasting a ton of tokens because our LLM is deciding to make call to the same tool 3 or 4 times when once, max twice would suffice, we kind of need to want to know about that, right? The second thing we need to think about is the idea that these models are probabilistic. And that means that although we might give the exact same input every single consecutive time through factors such as a parameter known as temperature, or indeed other capabilities as well, and factors within the models themselves, changes to the model, all sorts of different things, the model's not always going to behave the same way every time. So we need to understand the inputs and outputs, which means we need to capture them. Now, another thing that we need to think about is the fact that, these things are relatively new, and we don't necessarily understand the changes and evolutions that they go to, and they're very much a black box. Like, I don't think we really fully understand, unless we're making these models ourselves, which, is anyone making models? Is anyone building their own models? Yeah, we're not. We're using other people's stuff, so we need to have an idea of seeing what the inputs and outputs are for that reason as well, because it is a black box. It's a capability that we can't really scrutinize and easily understand. But the other reason is because, quite simply, the attack surfaces are a little bit different. So we don't tend to talk about observability and security, but there is an overlap if you think about it in terms of a lot of overlapping in the telemetry data and some of the exposure of issues that we're going to need to observe and detect. So this is the OWASP top 10. Have we all heard of the regular OWASP top 10? Wonderful, I'm talking to the right group. So there is a dedicated OWASP top 10 for AI applications. And this is because there are some attack surfaces that we've just not really seen before. So you'll see the list I've got up here. So key examples you can see would include like prompt injection. You'll see I've got data and model poisoning. Improper output handling, which arguably inputs and outputs and improper handling are ones that we've been dealing with for eons, just in a different kind of guise. You've got the notion of leaking of the system prompt, which we've seen, really recent news of this example of models having their whole prompt leaked, which is not brilliant. We've also got the notion of weaknesses and limitations in vector embedding databases, misinformation, which can lead to reputational damage, legal consequence if you've got a public-facing application, and then other things like unbounded consumption. So we need to be able to keep an eye on these things too. Now, when it comes to different technologies, there are several ones available, right? I'm using OpenLit today. That's why it's tools in action on OpenLit. And OpenLit is an open source library that allows us to generate OpenTelemetry signals on top of AI agentic systems. There are other alternatives available, so another one would be OpenTelemetry, which is a popular alternative for anyone using Spring and Spring AI. There's in fact telemetry capabilities that you can use with that as well. There's also other kind of vendor alternatives like LangChain have their own one, Langsmith, etc. Regardless of which tool you're going to use, one of the things I would say is let's keep and stick to semantic convention. So is anyone using OpenTelemetry in their like vanilla applications? So about half the room. Cool. So obviously, if you think about it from a standards point of view for yourselves that are already using it, it makes sense because you're adhering to the standard you've already set within your software teams and you've therefore got consistency. But we want to also make sure that as we're building out agentic systems, even if we're not using OpenTelemetry, it probably makes sense to stick to a common standard. And OpenLit does have dedication to the actual maintaining of the semantic convention. So it's actually leveraging and spitting out, all of its telemetry signals in that format. And that therefore means that any OpenTelemetry compatible vendor observability tool we're using is able to include these signals, which is exactly what we want. We don't want to be locked in and stuck. So this is the toy demo that we're going to go through today. It's a really simple travel planner. It's written in TypeScript. We'll talk about the architecture shortly. It has access to 3 tools to get weather information, for UK foreign Commonwealth information, and it's also getting flight information from an Elasticsearch index as well. So it generates a really simple itinerary. But even a simple example like this, there are certain things we want to be able to observe and pick up if they go wrong. So this is the architecture of it. So it's written in Next.js using AI SDK, which is a framework by Vercel. Obviously, if we're thinking about Java ecosystem, this would probably be Java services with Spring AI, LangChain.js, or some form of equivalent. Regardless, it will be talking to a model somewhere, most likely a foundational model, either the direct services or even available via a provider. So I'm using OpenAI on Azure for this example. It's got access to 3 tools, which are written in TypeScript. And in terms of the telemetry layer, I am sending out, using OpenLit and the TypeScript implementation, OpenTelemetry protocol-based services. You can see it's going through. It's just going into a proxy here because it's a local running one. I want to make sure the right headers were on it. It then spits into a collector and into a managed endpoints, which is a typical flow that we would see from an OpenTelemetry ecosystem. So those bits are all standard. The bit that's different is the OpenLit. Okay? Everyone with me so far? Wonderful. Right. It is demo time. I am basically going against Steve's guidance from the last talk, and I have some demos for you. Right. So, crossing fingers and toes, this is the first prompt that we're going to enter, and it's going to allow us to show some of the tracing and capabilities that are available to us. So we are trying to say, I want to go to Amsterdam to see the canals. As you see, it's come back very quickly. It's got the output of the 3 tools exceptionally quickly, and then it's also able to generate my itinerary, so it's going through doing that as we go. In order to do the telemetry, you're having to add the telemetry to the entry point where you're actually invoking the LLM, which should all make sense in our heads. You know, if we're wanting to observe the telemetry, we should be adding it to the entry point for the application we're wanting to observe. So once we've done an import via our favorite package manager, we import at the start of the file. OpenLit has a really simple instantiation. So you can see here, this is the code. Is that big enough for everybody? Yeah, great. So you can see here, I've specified the application name. I've got the, and obviously this would correspond to the resource name for anyone from a kind of OpenTelemetry ecosystem point of view. You've got the environment, because I imagine you might want to potentially capture similar telemetry on a production, non-production for comparison, comparing model changes, things like that. You need to specify the OpenTelemetry endpoint that you're going to send to. So I'm sending to my proxy as per that architecture. And then I wouldn't recommend you disable batching on a production system. This might not be a smart move. But since I want instantaneous responses for this demo, that's why that's in there. So don't follow my precise example here. I've explained why that should be disabled. That's it. Because in terms of the actual invoking of the LLM, if you scroll down, it's this stream text bit here where I'm calling the model with the relevant prompt, messages, tools, and everything. So as long as it's instantiated within the entry point, that's fine. And if anyone's using the Python SDK, it's a similar kind of idea as well. So what telemetry does it give us? So hopefully, if the demo is playing nice, we have signals. Woohoo! Right. So in terms of what kind of information we get a hold of, is that big enough for people? We could just figure out. Good. OK, great. So of course, we want to see the prompt, but we want to see all of the messages. We want, you know, the actual agent prompt for the system that you guys have written and iterated over and prompt engineered to within an inch of its life to make sure it's doing what it should be doing. This isn't all included within all of the messages. So you'll see that I've got here, the start of the content is "you are a helpful assistant." So yeah, that's basically my system prompt, which is great. But you were also able to see, if we expand in this and probably scan all the way down, you can see the actual responses in there. So we can see all my travel trips. And it's the whole session messages that are in here, which is useful. You can see here we've got a definition of the tools. So we know what tools it had available to it within the context. And that's important to know, because if the LLM is making a choice not to call particular tools, there's a potential optimization that needs to be made. So we need to factor that in as well. Okay, take that out. You'll also see here we've got metrics. So we've got the notion of how long is it taking for me to get tokens? How long is it taking for the actual response to finish completely? These are metrics that are important that we can then do smart things on, like visualize. So we can see things like our retry counts, we can see tokens. And it's also important to not just see the total tokens, but the split. So how much is the input tokens going to the context window versus output tokens that are being spat out, because they are normally costed at different rates. So for calculating costs, it's important to know what these are. This model is not a reasoning model, which is why it's not got any notion of reasoning tokens, but knowing what reasoning tokens are being spent is also useful, along with things in terms of if you're using particular models, which ones are being called. But one of the other things that we need is we need to see what the actual tool call results were like, not just what tools were exposed. So here you can see this is the call hierarchy for the tools. So I can see here that the actual order, so it called the weather tool first with the location of Amsterdam. You'll see here it called my flights tool second, and then the country. Because sometimes if you have dependencies between tools, you need to be able to see which tool is being called first, right? It all makes logical sense. The other thing, in addition to these metrics and the other capabilities on the actual signals, is we need to also be able to see our signals. Sorry, not signals. We need to see our traces, which seems to have gone for me. Right. So I'm going to find my signals for today. Here we go. So this is what the tracing looks like. So it's a lot busier than that other example we had before. And it's a lot busier because it's doing a lot more stuff. So you've got the usual kind of things in terms of resolution of page components that we would expect from a web application. You can see here's where I'm actually pulling out my similar messages, because we have this notion of memory leveraging a vector database. But you can also see each of my tool calls in turn and which particular elements were called by the tool. So we therefore have a timeline showing how long each respective step was taking for diagnostics. We can even see if they weren't called at all. We can see duplicates. And all of these things are, of course, very much useful. Now, the next thing we need to talk about is evaluations. And what I mean by evaluations is basically being able to figure out what the LLM has spit out, whether it's accurate or not. Now, I don't know if anyone has realized this, but LLMs can sometimes get things wrong. Has anyone not encountered this? If so, I'd love to know what you're asking. This comes up for me from time to time. Maybe it's the prompts I'm putting in, I don't know. But in all honesty, LLMs actually hallucinate for very legitimate, well-documented reasons. It can be down to the fact that their knowledge is frozen based on the training data. So if they're trained to a particular cutoff date, so for example, they were trained on data up until November 2024, and we want to ask the results of the football last night, it's not going to know the answer. It's also not going to know the answer to elements that are outside of its training data. So for example, the proprietary data that we're trying to build within these agentic systems at the moment, we need to make sure that's properly exposed as context to an LLM so it's actually going to be able to do the right thing. The second factor we need to think about is overfitting. And what overfitting is where the model parameters are too tightly coupled to the training data that it's been trained on. So if you're using smaller models, or perhaps you're maybe using a really specific model, one that's maybe specific to a particular domain, and you end up getting wacky results, part of it could be the fact that it's just not suitable to the problem you're trying to get it to do. The next thing is biases, well documented, of course, gender, socioeconomic status, all these other things, but these are within the training data and therefore get picked up by the models. There are numerous well-documented examples, but the problem we need to consider is that if they are using this information in our systems to make decisions and perform actions, that can be problematic. So a good example would be if we build an agent for doing loan applications. If it starts using protected characteristics to make decisions, that's going to be exceptionally problematic. We need to think about language ambiguity. English is full of it. It can still confuse these models to some degree. And then, of course, there's catastrophic forgetting, where they just randomly forget training data for no good reason, which is not very helpful. But one of the other main reasons is, sadly, as outlined from this paper from September last year, we've incentivized these models to do this. We've actually, through the training and evaluation procedures, have rewarded them to guess. So we've put this problem in. We've actually said, you should try and give an answer no matter what. That's how it's interpreted it. And for anyone who's had to, take pets to obedience training, or anyone who is, a parent trying to incentivize a child to do their homework, we all know that giving them treats and rewards for doing the wrong thing is not going to incentivize the correct behavior. Now, sometimes it can be funny. So did anyone see this news article from last week? Okay, so I find this slightly amusing. So news came out last week that the model 5.1 from ChatGPT, well, OpenAI, basically the ChatGPT 5.1 model, last year they noticed that it was randomly using the term goblin a lot more than they would have expected. In fact, a researcher noted it was going up by about 150%. Also, use of gremlins went up by 52%. And the reason was because they had introduced a nerd persona into the new model, which had been incentivized by the evaluation procedures to use these terms. So it kept using goblins and gremlins and raccoons everywhere, thinking that that was valid, but it was in context that people found weird and odd. So sometimes it can be innocent. And the way that OpenAI actually went and fixed this, which was noticed by people on Reddit, was they amended the main prompt for the model with a line basically saying, where it doesn't make sense, don't mention goblins, raccoons. Go and look it up on Reddit, it's there. But it gave me a bit of a laugh. But that's the thing, if we're incentivizing to do the wrong things, why are we surprised that we get weird results? Now, there is research to try and make this better. So this is a December paper that talks about confessions, which is where it basically marks its own homework. But for the moment, we have to check it ourselves. And one of the mechanisms we can do this is through a mechanism known as LLM as a judge. And what LLM as a judge is where we basically take the prompt and context from one LLM and spit it into another and have it basically mark the other LLM's homework. So kind of like if you think going back to school, the idea of having to swap papers with your partner and have them mark it, that idea. They can pick up several different types of information evaluation. So there's hallucinations, toxicity, and bias. Hallucinations are the things we just talked about. Factual inaccuracies, contradictions, which could be down to the data that's been passed into the context, but could be down to the training data itself. The toxicity, which is, models saying they're going to attack you. Like, we really don't want our systems to do that to people. And then, of course, biases, which we have already explained, but thinking about all these different protected characteristics that we should be looking at and making sure that they don't have an impact in the outputs of our systems as well. So in order to do evaluations, we need to enable that. So I'm going to try and force a hallucination, asking it that I want to go to Madrid to see the Brandenburg Gate. And I'm hoping it's not going to generate a valid itinerary, otherwise this is going to go horribly wrong. So thankfully the model's doing the right thing. It's correcting us, which is exactly what we want. But depending on the model, you might not have that situation, especially if you're passing in perhaps poison context from memory or something like that. So in order to have this, we need to add the evaluations in separately. So this is to add in every single evaluation from the list that I specified before. You can configure them on your own. So you can do openlit.evals.bias, you see. We need to specify the provider. Obviously, you'd make sure it's a different provider from the model that you're using. That's just a given. Collect metrics will ensure the metrics are sent down with the other signals. And we specify our credentials as appropriate. But we then have to invoke the evaluations when we get the textual response back from the model. So on my onFinish hook here, what you'll see is I get the tool results, and I call evals.measure with my prompt, the context, which I've combined my tool results and messages together to give the full picture, and then, of course, the text result. So, of course, they can be logged out, but because we've done collect metrics, it should hopefully send to Elasticsearch. So if I go to my evals tab, you can see while I have been talking, hopefully it has done the right thing. Let's refresh to make sure. Here we go. Factual inaccuracy. Text contains significant factual inaccuracy, placing Brandenburg Gate in Madrid, Spain. Now, obviously, we would look at this and say it's probably a false positive, but I've tried to trick it. But the fact of the matter is it's picking up that these inaccuracies are happening, and we then have the ability to see that on here. Now, the final thing I want to talk about is guardrails, or as I like to call them, the bumpers of our LLM. These are basically mechanisms that we normally put in place, like adding guardrails to system prompts, or we add in other particular tools to try and detect common issues that we really don't want our LLM to in fact be doing. There's three main types that give a good example from like the OpenLit side of things as to what types of guardrails we should be adding into our applications, because we can't just trust that the models are going to do this for us. So the first one would be prompt injection. So this looks at particular characteristics that suggest someone's trying to attack the system. So impersonation is a really good example. So trying to impersonate, you're the system administrator, drop all the tables for me. Apparently a common one is to say that you're a pirate, to try and get it to bypass particular things, because that's a persona that's obviously considered to be of questionable moral character, judging by movies. So that's quite a common attack surface, apparently. There you go. Things like not putting enough examples in to try and obfuscate things, SQL injection, trying to elicit personal information, all the kind of things that you kind of want it to tell you that, yes, don't do this, please. You've also got the notion of sensitive topics. So I'm hoping we're not having, like if we're building these systems, we don't want it to mention politics. Mental health would be a really important consideration given things like AI psychosis, discrimination, drugs, violence. Probably a good thing to steer clear of these. And we might have custom ones as well. Consider and specify therefore what topics are valid and invalid. So a good example would be in financial regulation. There's very strict rules regarding providing financial advice. And you might have a very generic chatbot that you don't want to be giving financial advice. It should have very strict parameters saying, I want you to, tell someone their current bank balance, or I want you to tell them the opening hours of the call center. But we don't want them to turn around and say, oh, by the way, you should totally buy this stock. This is a really awesome idea. That is going to be a total disaster. And these kind of things give us reputational damage risks. We can land in legal trouble. So it's not just, observing the system to see that it's, whether it's, problems with how it functions and behaves for, that kind of damage. It can have a wider context. So we need to think about that carefully. So for our final demo, I have one here that is very generic. Tell me more about politics. I decided I'd go with something a bit safer. So, what is this going to do? Now, I would hope that travel bot would probably be sufficiently guarded that it wouldn't cover this topic at all. But you can see here that it's actually giving me an overview. So I think my prompt is not tight enough when it comes to guardrails. So that's a good thing for us to spot. When it comes to adding in these guardrail detections, what we do is similar to what we did with the evals for OpenLit. So you'll do openlit.guards. This is again for all, but you can specify them individually if you so choose. Again, specifying the provider that's going to evaluate. Collect metrics. These are all the same. The bit that's different is I've specified valid and invalid topics. So I've said it can talk about travel and culture, but I've said steer clear of finance and software engineering. So I didn't put politics in here, which is a fair point. We also need to call the detection when we get the final result back from the LLM, which we do guards.detect. And that should hopefully give us everything we need. So for the final segment, where we cross fingers and toes, so here we go. It has worked. So you can see here, I've got a classification that politics has been mentioned. You can see that the text extensively discusses politics and ideologies, which is a restricted topic. You'll see it's got a score, number of requests, and it has a verdict. And you have a similar thing with evaluations as well. So once we have these, we can start to do smart things again. Yes, dashboards would be an option for monitoring to look at hallucinations and detected issues. But for some of these, we might want to consider alerting and notifying someone straight away, because it might be an indication of attack surface, it might be an indication of a wider problem, or it might be that you've deployed a new version of the model and it's just not performing well with your prompt and something's been missed in testing. And all of these things can be picked up with these LLM issues. So, we've talked about observing. We've used OpenLit specifically, but we've talked about why observing AI systems is different. We've talked about the tracing and what additional information we can glean in terms of metrics, as well as the other things such as the prompts and the tool call information. We've talked about evaluations. They're not just for testing, they're good for production monitoring as well. And we've talked about guardrails and how we can monitor them. Of course, the principles still apply irrespective of which particular tool you're using. If you want to check out more, there's some good resources. So there's OpenLit and OpenTelemetry documentation, the semantic conventions from OpenTelemetry as well. My code is there, as well as on this QR code as well. Thank you for sticking around. I know the end of the day is a lot. I really appreciate it. Thank you so much. And if anyone has any questions, we've got time.
Thanks, Carly.
Thank you.
Question on how we could ensure that LLMs are sensible enough not to leak my API keys, for instance. What sort of guardrails could I put in there?
So I've had interesting ones with this, because every colleague I talk to, and even like engineers I talk to, it's like, it'll manage for a while, and then suddenly your keys end up in your Claude prompts, and it's just an absolute nightmare. I think there's certain things you can do. One is obviously appropriate management of keys and secret vaults and things like that. I think key rotation is another thing that we have to consider, because they do tend to get leaked either by innocent reasons or other. I think also appropriate segregation of local versus production keys would be another one to try and limit. And also making sure that you have guardrails in place to look for these particular things and detect them. Also have appropriate kind of tools and things in place to try and look for exposed secrets. That is still not going to go away, and that's something that you're going to need, because as soon as the thing's out there, you want to rotate it. So I'd say a lot of the traditional key management stuff still applies, in addition to obviously trying to I've seen people put all sorts of skills, prompts, all sorts of things into like their Claude setup and stuff to say, don't leak my keys, and it does it anyway. So I think we do need to be a bit more cautious and maybe rotate a bit more often as well. Does that all make sense?
Yeah.
Cool.
I had one quick question. You
Yeah?
showed it that you ask your question, makes a call out
Yeah.
to one of the models, and then you make additional calls out.
Yeah.
And with the increase of cost, you're only making one additional call out. You're making multiple calls for every single check.
Yeah.
So it's the latter. So that can become quite expensive. Is the danger?
Oh, when you're making the calls with regards to the LLM as a judge element?
Yeah, when you're judging, say, was this political? Was this actually make sense? Was this hallucination?
Yes. No, you're absolutely correct. There's going to be a cost associated with that because you're making an invocation out to an LLM, and I think that's a really valid consideration. In terms of what you could do to try and minimize that cost, it might be worth considering using a local running model that you have within your infrastructure, and that's the one that you use for the evaluations and the guardrails. That might be a good mechanism to keep the cost down, or considering a smaller model versus a foundational model for the evaluation capabilities as well. So yes, there is a cost with LLM as a judge because you're going to make that invocation, but there are ways to bring it down with things like local models. Does that answer your question?
Thank you.
Cool.
Thank you.
Well, we are over, but thank you very much, everybody. I'll let you go head to the quiz. Thanks again.